Hi, I am Aditya. I'm walking you through my submission for the Amboras Store Analytics Dashboard assignment. This is a full stack application built with Next.js on the front end and Nest.js with a Postgres and Redis on the back end. I'll first show you the product demo, then I'll walk you through the main code decisions, and I'll end with a short reflection of it. As you can see, I'm starting with the login page. I'm using one of the selected demo accounts from here. You can choose any one from it. Each user belongs to a store, and that store relationship is important because the app is multi-tenant. After logging, the backend returns a JWT token, and that token is used to make sure the user only see analytics for their own store. So moving with one of the demo credentials. As you can see now, I am on the dashboard. At the top, I can immediately see the main business numbers like revenue today, revenue this week, conversion rate, tracked events. Then I have charts for revenue windows, traffic mix, conversion funnel, live rhythm, store pulse, recent activity, product leaders, and all. Uh, the goal here was to make the dashboard useful at a glance, not just visually nice. I also added a date range which I can change between today, 7 days, and 30 days, and the dashboard reloads the analytics for that time window. This makes the same dashboard useful for both quick daily checkup and a broader business view. Now I'll show you the real time part. I can check the simulate purchases. Which basically sends a purchase event to the backend. As soon as that event is created, the dashboard updates without reloading the page. The recent activity feed updates and the top matrix and chart refreshes as well. I also added a refresh button, as you can see it here, so I can manually refresh the latest data whenever I want. So let me simulate the purchase once again for you. As you can see, this is the dollar bill. This is added to revenue today and all the other cards here, and as well the chart has been updated for it with the purchase layer, and the main thing is recent activities that is updated with the recent dollar bill purchase. So the live update behavior is one of the bonus features. I used server sent events or SSC for the push from the backend to front end. I also kept polling in the front end as a fallback, so the dashboard still stays fresh even if the live stream drops for some reason. I'll also quickly show you the UI is responsive. So collapsing it, as you can see, the dashboard adjusted itself for the expanded layer, and scrolling through, and also when coming to the small size screens, like for example iPhone XR or something like that. As you can see, the dashboard adjusted itself and is responsive for this device as well. So this covers the whole product demo. Now I'll switch to the code and walk you through two important parts, that is analytics aggregation on the backend and live refresh flow between backend and the front end. As you can see it here, the analytics controller is responsible for exposing the endpoints, protecting them with the JWT auth, reading the current user store ID, parsing query parameters like date, range, and limit, and then calling the service layer. So the controller is basically the HTTP layer. And now moving on to the service layer. The analytics service is where the real work happens. It handles the aggregation logic, checks the Redis cache, runs Prisma queries on Postgres, calculates revenue and conversion metrics, returns the response data, and also invalidates the cache analytics when new events are created. For the overview endpoint, now I am doing a query time aggregation instead of pre-computing everything. The service uses Postgres through Prisma to calculate revenue, event counts, page views, purchases, and conversion rate. I run the main queries in parallel using promise.all and then cache the result in Redis for 30 seconds so repeated dashboard loads and stay fast. Now moving on to the event.controller, that is the event layer. I'll show how the real-time event flow. When a new event comes in, the backend stores it in the dashboard, basically a database, and then emits an internal event. That internal event is used in two places. One part is invalidate the cache. That is, this is the main layer, that is event service. The one layer invalidates the cache, and the one layer listens to the SSC. So, and now in the front end side of things, This is the main hook, that is use dashboard hook. So basically it fetches the analytics data and the live events hook that listens to the SSE stream. When a live event arrives, I trigger a debounce refresh. As you can see it here as well in the overview, top products and recent activity layer. Basically, it listens to the SSE stream when a live event arrives. I also fix the refresh logic so that manual refresh and live refresh both use the latest updated date window instead of a stale timestamp. And for one thing, I also want to highlight is a tenant isolation. Each logged in user belongs to a store. As you can see it here as well, Teach Gear Store dashboard. This is basically contained for the Teach Gear Store. So I chose a simple and practical architecture for it. So even though the data is stored together in the same system, each merchant only sees their own store's data. That was one of the core requirements. So I basically made sure it was enforced in the backend query layer. The biggest challenge here was balancing performance and simplicity. It would be easy to over-engineer this with a much more complex event processing system, but the assignment specifically values your trade-offs. So I chose a simple and practical architecture. Postgres as a source of truth, Redis for cache, as you can see it in the system overview as well. Postgres as the source of truth, Redis for cache, SSE for the live events, and SWR for the front-end events. And if I had more time, I would improve cache invalidation for all custom date ranges, add automated tests around analytics and auth, improve SSE reconnection logic, and probably add pre-aggregated rollups if the event volume got much larger. That's the full walkthrough. To summarize, this project includes authentication, multi-tenant analytics, fast aggregate APIs, charts, responsive UIs, and real-time updates. My focus was to keep it useful, fast, and easy to reason about. At the last, I also want you to walk you through the whole diagram, that is the dashboard load read path. So as you can see, this is the sequence diagram for it. And moving on, we also have a real-time design flowchart, that is how the real-time system works with the flowchart in it, and the multi-tenant security model, as you can see it here as well. So the post, then validate, then issue JWT, then basically JWT auth guard validates the merchant, then current user exposes all analytics queries, then tenant isolation dashboard happens. Basically the tenant isolation happens and the dashboard is shown with the isolated tenant. So thank you for watching. This was the whole overview of the application. Hope you like it.